Hello and welcome everyone. In this video we'll continue solving past papers from grade 12 previous years. For today, the first question, it says f of x is equal to x plus 1 over x minus 1 and f of a equal to 5 given to you already. Then we need to find f of 2a. Okay, so first of all, let's try to find the a value from here. F of a is equal to 5. What means f of a? Substitute a in place of x in each place. It's going to be a plus 1 over a minus 1. This is equal to 5, already given. Then we can use crisscross. When you multiply crisscross, it's going to be 5 will multiply each of them. So 5a minus 5 is equal to a plus 1. Then collect the like terms, bring the a here. It will be for a is equal to 6. So the a value is equal to 6 over 4, or we can say 3 over 2. This is a. Then we are asked f of 2a. That means f of 2 times 3 over 2. We have got already the a value here. Here. Then cancel the 2. So what left? F of 3 left. F of 3 means substitute 3 in place of x in the original function. That's going to be 3 plus 1 over 3 minus 1, which is 4 over 2. So f of 3 is finally, the answer will be 2, which is found in A. That's it. The second question. The second question here, it says okay, it says f of x is equal to cube root of 1 plus e the power of negative x. Then we are asked to find the inverse of x. So first of all, f of x is the same as y. Y is equal to cube root of 1 plus e raised to negative x. This is given to us. So we need to find the inverse. So that means in place of y, write x, and in place of x, write y. 1 plus e the power of negative y. We can write. Okay, we can exchange place of x and y. And then try to solve for y. To get for y, there is cube root here. The y is exponent of e here. Therefore, to get the y, okay, we need to remove the cube root here first. That means the reverse process of cube root is cubing. So cube both sides. So we left x cube is equal to, okay, the cube root cancelled by the cube. 1 plus e the power of negative y left. Okay, the next step, try to shift the 1 to the other side. So x cube plus 1 is equal to e the power of negative y. So we are here now. E the power of negative y is equal to x cube plus 1. Therefore, to get still the y is the exponent of e. We need to take both sides ln. Ln means, natural logarithm. For example, ln of a means it is the same as logarithm of a to the base e. So we will take both sides. Ln means we will take logarithm of logarithm with base e. That means what left? Y, the negative y will left here. The other side, ln of absolute value of x cube plus 1 left, the right side, because here ln of e means just 1, and the exponent negative y will come as a coefficient, and it's going to be negative y only. Therefore, multiply both sides by negative, so the y value will be negative of ln of absolute value of x cube plus 1. We can rearrange. This negative 1 will be an exponent here, then it will let the whole expression here, it will be denominator. So the y value will be ln of the absolute value of 1 over x cube plus 1. That's it. The answer is going to be A. Okay, let's go to the next question. Okay, the next question, it says if p of x is equal to 3x, p of x is equal to 3x given, and q of x is equal to x squared plus x, then what is the solution set of p of x over 3q of x minus 1 over x equal to 1 over q of x? So let us substitute everything what we have, especially in place of p of x and q of x. Let us insert 3x squared. Okay, let's do it. It's going to be 3x squared, the whole over 3 times q of x means I'll multiply this one by 3. It's going to be 3x squared plus 3x minus 1 over x is equal to the right side, what we do have 1 over q of x is x squared plus x. Then here let's take out the common in the denominator. It's going to be 3x squared over What's common? It's 3x. Then what left? X plus 1 left. Minus 1 over x is equal to 1 over x common, x plus 1. At this point we can cancel 3 here by 3, and x cancel 1x, just x left here. So what we have now, x over x plus 1 minus 1 over x is equal to 1 over x into x plus 1. We need to take care here one thing. What is that? The x cannot be 0 and the x is different from negative 1. X over x plus 1. Yeah, the whole over 1 over. So here x should be different from 0 and negative 1. We need to know that. Why different from 0? Because if you substitute 0, this is going to be 0. It's undefined. And negative 1 also, it will make undefined. Then what is the LCM of the denominators? The LCM of the denominators will be just x and x plus 1. If you try to observe the denominator, there is x plus 1 here, there is x here, there is x and x plus 1. The denominator LCM will be x into x plus 1. Then you can multiply by it. It's going to be x over x plus 1 times x into x plus 1 minus 1 over x times x into x plus 1, we are multiplying, is equal to 1 over x into x plus 1, then again times x plus 1. This time we are trying to find, we are trying to remove the denominators function. So x plus 1 cancelled and x squared left, minus here x cancelled, just x plus 1 left, but there is negative here. Don't forget the negative will be distributed. X minus 1 will be equal to the right side, everything is cancelled out, just x left. So let's go to the next page and finalize it. But before we go to the next page, here we need to correct it. That is just x only, no, just 1 at last. Here when you cancel everything, 1 left, not x. This is going to be 1. So x squared minus x minus 1 is equal to 1. Okay, let's go to the next page. X squared minus x minus 1 is equal to 1. We are here. Then bring the 1 here. It's going to be x squared minus x minus 2 is equal to 0. It's quadratic. So we need to think of two number product, which is negative 2, and the sum, which is negative 1. Those numbers are, it's negative 2 and 1. If you multiply, you'll get negative 2, and if you add them, it will be negative 1. So that when you factorize this, it's going to be x minus 2 and x plus 1. You can do it by formula even to solve this inequality. Is equal to 0. That means x is equal to 2 or x is equal to negative 1. But x is equal to negative 1 cannot be an answer. The reason, because we restrict the domain. The domain, we said any real number without what? Without negative 1 and 0, we said already. So as you see, the negative 1 is the one which is excluded. So the answer will be, or the final solution set will be just only 2. So the answer is found in B. Look, but the answer in A, if you try to see it, it contains negative 1 and 2. We have got those. So through process, we need to take care about the domain also. So the answer is going to be B. Okay, let's continue to the next question. Okay, the next question again, it says, what is the solution set of 1 minus 1 over x, the whole over 1 minus 1 over x square equal to 3x square minus x over 1 plus 1 over x. So we need to do the numerator here separately, this also, and then we'll flip it the same manner here. First we have to do these two. Okay, let's do it. When you do, we can use crisscross here, because this denominator is 1, here also denominator 1, here also denominator 1. Okay, let's do that one. When you use crisscross, it's going to be x minus 1 over x, that is the numerator part only, the whole over. Again, when you come to here, it's going to be x square minus 1, the whole over x again, is equal to 3x square minus x over, let's do the denominator here also, x plus 1, the whole over x, that's the denominator. Okay, the next, by the way, here we need to take care, x is different from 0 and 1 and negative 1. What you see, this will be 0 at 0. Okay, the denominator, where does the denominators, okay, 0. Here it's going to be 0 at negative 1. Here also it's going to be 0 at negative 1 and 1. So the whole 0 points of the denominator, or the one which makes the whole function undefined, will be excluded from the domain. So our answer should not contain those points. So even in the choice, when you see the one which contains 0 and 1 or negative 1 will be excluded. Okay, the next step, we'll flip this one. It will be x minus 1 over x times, okay, this one will be flipped, x over x square minus 1 is the same as x minus 1 and x plus 1. We can factorize, is equal to 3x square minus x times x over x plus 1. What did I do here? I flipped this one. So here cancel x minus 1. Okay, and this denominator is x square, as you see. This one is x square here. So that means when you flip, this will be x square. So cancel one x also, just x left here. Okay, let's write it here. What left? X over x plus 1 left. X over x plus 1 is equal to here x 3x square minus x square over x plus 1 left, because x times x is x square here, and this denominator is 1. When the denominator will multiply. Okay, now this denominator 1 here. So what is the LCM of the 3? The 3 of LCM is just x plus 1. We'll multiply by x plus 1 by x plus 1 and by x plus 1. Okay, let's go to the next page and write as it is. Okay, so it's going to be x over x plus 1 times x plus 1 times x plus 1 times x plus 1, each of them, because the LCM. Then cancel here. What left? X is equal to when you multiply, it's going to be 3x square in bracket x plus 1 minus just x square left here, because this cancel each out, and then divide by x. It's okay, because we already restrict the x value cannot be 0. What left here? It's 1 is equal to here the x cancel, 3x left, multiply 3x plus 3x square plus 3x, because there is 1x, and when you multiply 3x square plus 3x minus x, which is now when you like collect everything, it's going to be 3x square plus 3x plus 2x minus 1 is equal to 0. Then here we need to think of two numbers, product negative 3 and sum, which is 2. These numbers are 3 and negative 1. When you multiply negative 3, okay, so when you do that one, it will be 3x square plus 3x minus x minus 1 is equal to 0. Then take out common here for these two. It will be 3x and x plus 1 minus 1 into x plus 1 is equal to 0. Then x plus 1, then 3x minus 1 is equal to 0. So the two answer finally will be x is equal to negative 1 and x is equal to 1 over 3. But this one doesn't work, we said already. We restrict the domain, x is different from 0, negative 1 and 1, we said already. So the answer will be x is equal to 1 over 3. Let's get back and see it. The answer will be found in B. It's here. The A, look, you need to take care. It contains both of our final answer, but the negative one doesn't work because we already restrict the domain. Here it is. So that's the way how to solve the step-by-step process. Okay, let's continue to the next question. Okay, the next question also, it is the same as like that of the previous one, but somehow different. It's different year exams, so sometimes similar question may appear. So 1 over, again here we have to solve this denominator first, and here also this denominator first, and this one and this one also separately. Let's do it. So it will be x plus 1, let's use white marker, x plus 1 over x minus again 1 over x minus 1 over x is equal to x square plus 1 over x, that is the numerator part, the whole over again x square minus 1 over x. Next step, it's going to be x over x plus 1. We need to flip this one because it's 1 over minus the same manner x over x minus 1 is equal to x square plus 1 over x times x over x square minus 1 is the same as x minus 1 and x plus 1. So when you flip it, the denominator is going to be x square plus 1 over x times this, the denominator will be flipped, x over x square minus 1. It will be factorized x minus 1 and x plus 1. Then cancel the x here. What left? X square plus 1 over x minus 1 and x plus 1. It's written here as you see. Now when you try to observe the LCM of the denominator, there is x plus 1 here, here also there is x plus 1, there is x plus 1 and x minus 1. So the LCM will be x minus 1 and x plus 1. But take care again here, the domain x is different from 0, 1 and negative 1. Doesn't work. Therefore let's multiply it. Let's go to the next page. Okay. Okay, before we go to the next page, this will be minus 1. We need to correct it. This one middle term is negative 1 because here as you see it's minus 1, so this must be negative 1. Okay, let's continue to the next page. So we have here everything. This is going to be minus 1, so we'll multiply by x plus 1 and x minus 1 is equal to x square plus 1 over x plus 1 and x minus 1 will be multiplied with x plus 1 and x minus 1. Therefore you can cancel everything here. Here x minus 1 cancel, here x plus 1 cancel. Then what left? X in bracket x minus 1 minus x in bracket x plus 1 is equal to x square plus 1 left. Therefore multiply x square minus x square minus x again is equal to x square plus 1. Here x square cancel and negative 2x is equal to x square plus 1. When you collect and everything right as a quadratic formal equation, it will be x squared plus 2x plus 1 is equal to 0. Then when you factorize this one, it's going to be x plus 1 the whole square is equal to 0. That means x plus 1 the whole square is equal to 0 means you can put both sides. The radical doesn't matter, so x value is equal to negative 1 will appear. But unfortunately negative 1 is undefined point, it's not in the domain. So the solution set finally will be empty. We can write it in this way or just open brace. So the answer will be found in A. Yes, still the answer is found in A. Here it is. Okay, let's proceed to the next question. The next question is again its inverse. The function f of x is equal to 8x cubed plus 2. So we need to find the inverse. So in place of f of x we can write y is equal to 8x cubed plus 2. The step is clear. So in place of y write x and y 8y cubed plus 2. Then try to solve for y. Bring the 2 to the left side. X minus 2 is equal to 8x cubed. Then you can put both sides and divide both sides by 8. Therefore what left? X cubed is equal to x minus 2 over 8. This is not x cubed, it must be y cubed because already we said it y cubed here. We are trying to solve for y. Therefore y is cubed. To remove the cube we have to put in cube root both sides, or we can multiply the exponent of both by 1 over 3. It's better to put in cube root both sides because the cube root is a reverse process cubing. So y is equal to cube root of x minus 2 over cube root of 8. You can give the cube root for each, for numerator and denominator. So it's going to be cube root of 8 is 2. So 1 over 2 cube root of x minus 2. Or let's write it down. It will be clear, more clear, better. Now the inverse. Y means the inverse of x. So f inverse of x will be 1 over 2, then cube root of x minus 2. So the answer is found in B. Yeah, it's here. This is inverse function like that of our previous question. Okay, this is our question number 9 for today. Let's continue for question number 10. Here it is. Okay, what does this question says? F of x is equal to cube root of radical x cube. This is f of x, and f of g of x is equal to 4th root of x. These are given. Then we are asked to find g of 8. Okay, so what we can do here, first of all, let's take this one, this expression, the whole. What I say, f of g of x, this f of g of x is given to you 4th root of x. So we need g of 8, so we can replace in place of x 8 here also, it will be 8. So f of g of 8 is equal to 4th root of 8. But we know that f of x is equal to what? F of x is equal to square root of x cubed. So in place of x, here what you see is g of 8. So we will substitute g of 8 in place of here, in place of x, because if this y is going to be y. Okay, if the x varies directly, this also the inner one will vary. So if this y, it's going to be y. So the same manner, consider this one like y. Therefore, g of 8, the whole cube in the square root, is equal to 4th root of 8. What does this mean? G of 8, the whole the power of 3 over 2. Why? Because the index here 2. So the index will be the denominator, you know. The exponent remain as it is equal to 8 the power of 1 over 4. So our objective is to get g of 8. So we need to multiply the exponent by what? By the reciprocal of itself, by 2 over 3. Here also we'll multiply by 2 over 3. When you do that, okay, let's line here. This cancelled out everything. And what left? G of 8. G of 8 left is equal to, here by 2 1, this by 2 2. So 8 means 2 cube, you know. The whole the power of the outer exponent, you know, 1 over 6. When you multiply 1 over 2 times 1 over 3 will be 1 over 6. Then by 3 1, this by 3 2. Therefore it left 2 the power of 1 over 2. This is g of 8. Still we are doing for g of 8. So 2 the power of 1 over 2 means radical 2. So the answer is found in C. That's it. Okay, let's continue to the next question. The next question, it says f of x is equal to x minus x square. Okay, here it is, f of x, and g of x is equal to 1 over x. And we need to find g of f of 1 over x. Okay, let's find it now. Okay, so at this point what we can do, g of f of 1 over x. This is what we need. First of all, what is f of 1 over x? Let's find that. F of 1 over x means I will substitute 1 over x in place of every x here, because we know f of x. F of x is here, this one and this one, x minus x square. So in place of x I will substitute 1 over x here, also here. So when you do that, it's going to be 1 over x minus 1 over x square. When you do this, okay, you can use crisscross or whatever process. We have to shorten our step. It's going to be x minus 1 over x square. This is f of 1 over x. So g of, now in place of f of x, f of 1 over x, you can substitute this one, x minus 1 over x square is the same as, you know, g of x is governed by 1 over of it. Okay, 1 over of the given. Okay, the function will be flipped, so it will be 1 over x minus 1 over x square. This is it, because g of x means, as you see, what does g of x is doing here? Simply 1 over of the given. G of x means 1 over x. So a given value here will be 1 over of it. It's here, everything. It will flip anyways. So when we take the reciprocal, it's going to be x square over x minus 1. Finally, the answer will be B. Here it is. Okay. Okay, the next question, it is again rational function. It says here, which one of the following is true about the graph of f of x is equal to x cubed minus x over x cubed onto x minus 1. Let's write it. F of x is equal to x cubed minus x, the whole over x cubed into x minus 1. This can be written, what's common for these two? It's x squared minus 1, the whole over x cubed into x minus 1. We can factorize x squared minus 1. It will be x into x minus 1 and x plus 1, the whole over x cubed into x minus 1. Then cancel x minus 1 here. Also 1x will be cancelled. So take care. X is equal to 0 and x is equal to 1 false. The graph will make whole at these 2 points. So what left now? The function is condensed or simplified and written as x plus 1 over x squared left. Okay, the degree of the numerator is 1 and the degree of the denominator is 2. So the degree of the numerator is less than the degree of the denominator, means the horizontal asymptote will be x-axis, or y is equal to 0. Now let us see the choice. And the vertical asymptote, take care here. This time the vertical asymptote is only x is equal to 0, because the denominator 0 points, it's just x is equal to 0. But x is equal to 1, it is also a whole. Even at x is equal to 0 exactly, it will make a whole. So already we said it will make whole at x is equal to 0 and at x is equal to 1, because we cancelled out already. So it has no vertical asymptote. Necessarily the vertical asymptote at last it will be x is equal to, x squared is equal to 0 means at 0 point. But here the 0 is already the whole, so it will not have a vertical asymptote this time. So what does it say here? The vertical asymptotes are 0 and 1. No, they are wholes. And the horizontal asymptote of the graph is y is equal to no. The horizontal asymptote is y is equal to 0, because the degree of the numerator is 1, the degree of the denominator 2, it's less. And the graph intersects its horizontal asymptotes. The horizontal asymptote is x-axis. So does it cross the x-axis? Let's check. How to check? Just make the whole function is equal to 0. That means x plus 1 is equal to 0 in another way, because by crisscross the denominator cancel. So at x is equal to negative 1. Okay, that means at negative 1 comma 0 it crosses the x-axis. That is true. So the answer will be C. Okay, the next one, D, it says the graph intersect the vertical. No, vertical asymptote cannot be intersected. At this time it has no even vertical asymptote. Let's continue to the next question. The next question, which one of the following is a one-to-one correspondence function? One-to-one correspondence means it has to be both one-to-one and onto. To be one-to-one correspondence, okay, to be one-to-one correspondence, the given function has to be one-to-one and onto. One-to-one and onto means everything what you see here as a domain. Okay, these are pre-image and these are image. So everything what you see here, the domain, it has to have unique outcome here, and everything what you see in the image should have pre-image. Okay, let us check that. When you do that, okay, the first function is f of x. F of x is equal to x. What is the smallest number what we can insert from the domain is 0, and the largest number is 1. Okay, let us insert both of them and let us see the outcome. So f of 0, if you substitute 0 here, it will be 0, but there is no 0 in the range here. There is no 0 here, so it doesn't work. This one fails at this point when you are doing for a, because when you substitute 0, the first one, okay, every input it should have output. We substitute 0, it has no the outcome what we got here, it's not in the range, so it doesn't work. It's not one-to-one correspondence. Okay, B, it says f of x is equal to 1 over 3 x cubed plus 1. Okay, again here let's substitute 0. When you substitute 0, it's 1. Okay, 0 just 1 works. What about the last one? Substitute 1. When you substitute 1, it will be 1 over 3 plus 1, which will be 3 plus 1 is 4 over 3. 4 over 3 is less than 2. So the 2 has no, this is the maximum outcome that we can have here. for this function. The maximum outcome is 4 over 3. 4 over 3 is less than 2. It's less than 2. So the number 2 has no pre-image. That means in another way, this 2, it has no pre-image according to B, because the B maximum outcome is 4 over 3. It's not 2. So 2 will be without pre-image, so it doesn't work. To be on one-to-one correspondence, it has to be one-to-one and on 2. So the 2 has no pre-image, means it's not on 2. Okay, what about C? Let's continue and check. C, f of x is equal to, it says, to x plus 1. Let us substitute 0. F of 0 is, it's 1, and f of 1 is 3. You see the 3? The 3 is not found in the range here. When you substitute the maximum outcome in here, okay, the largest input is 1 here. When you just put it 1, the outcome is 3. The 3 is not found in the range, so it's not one-to-one correspondence. What about C? D. When you put D, f of x is equal to x squared plus 1. What is f of 0? It's just 1. When you substitute 0, okay, it works. What about f of 1? When you substitute 1, it's going to be 2. Both of them works. Okay, the smallest input will give you the smallest output, and the largest input will give you the largest output. That means it is one-to-one correspondence. So the answer is D. So this is it, enough for today. I hope you enjoyed it. Don't forget to subscribe and share to your friends. More videos are coming. Make yourself stronger and prepare for the upcoming national examination. Thank you for watching.